Okay, good morning. So last class we have seen the basics of nature of light. That is, we have seen about what is critical angle, what is acceptance angle, and what is Snell's law, what is angle of incidence, what is angle of diffraction, then what is what is numerical aperture. So very important. So numerical aperture means it defines how much that is light efficiency, or we can say it defines the fiber how much light it can permit, how much light it can permit in the fiber. It is very important. Numerical aperture n1 minus n1 square minus n2 square power 1 by 2. Okay, in this class we are going to see about some basics, some different types of fiber, that is fiber structure. So normally if you take an optical fiber, so there are main part is core. There only light can be traveled in the form of total internal reflection. Then we have got that is it is covered by the portion that is called cladding. Okay, cladding, the main purpose of cladding is used to provide the mechanical strength as well as used to reduce the scattering loss. Very important 2 mark question. They will ask what is the use of cladding in optical fiber. So there are two use mainly. It provides mechanical strength as well as it reduces the scattering loss of core. Okay, most of the fiber that is in core we have to take in that is glass material. So there are two materials normally we are having. One is called glass material and one more is called plastic material for manufacturing the fiber. Glass material offers low loss or medium loss, but plastic fiber, when we compare with plastic fiber, glass fiber offers very less loss. So mostly most of the applications they will prefer only glass fiber. Okay, cladding, either it may be either plastic or it may be a glass. So cladding main purpose is the cladding that is to use it is used to reduce the scattering loss as well as provides the mechanical support. That is the purpose of cladding. And another outer some flexible layers are there. It reduces the damages. Then if you are placing a fiber in a rough surface, it provides some flexibility. So there should be some outer layer we have to make. Overall, it provides the protection for core as well as cladding. So this is the structure. So simple. The structure consists of core. Then we are having cladding. Okay. Yeah. It may be a glass core. So the core diameter it may vary from 5 micron to 100 microns. Okay. And it is the size is very thin when we compare with cladding. The core is very thin when we compare with cladding. Glass, that is cladding, the refractive index of the cladding is lesser than the refractive index of core medium, because refractive index of core will act as a N1, refractive index of cladding will act as a N2. So for total internal reflection it should take place means we have to make N1 is greater than N2. Suppose if you are making N2 is greater than N1, then it is not possible to perform the total internal reflection. Then that is called total external reflection. So we have to make N1 is greater, that is N1, that is refractive index of core should be greater, then refractive index of cladding should be lesser. Then before going to the fiber, there are three rays are available. It is the rays means that is a light path inside the fiber. So there are how it is propagating inside the fiber based on the propagation type. We can classify into three. One is called skew rays, and one more is meridional rays, and one more is axial rays. Skew rays means we can you can see in this diagram. It follows in a zigzag path. That is called a skew rays. You can see that. Then meridional rays always crosses the fiber axis. Then that will transfer. That is called a meridional rays. Then axial rays means simply it follows through axial. That is called axial rays. So there are three rays are possible. One is called skew. Skew means it follows zigzag, does not cross the axis. Meridional means it crosses the axis and it will propagate. Axial means simply it follows axis. That is through axis, through fiber axis it will propagate. This is different types of rays. then we can have the different types of optical fibers. So normally we can, based on the structure, we can classify, that is based on the nature of the fiber fabrication, we can classify. One is called glass fiber and one more is called plastic fiber. For glass mostly they will use silica, it is for the glass fiber. And the basic fiber, it should have the following properties, then only it is it reduces the loss. One is it should be efficient to guide the light waves, then it should be very low scattering loss. The absorption, attenuation and dispersion should be less. So these are all the basic properties required for the fiber material to use in optical fiber communication. So there are two types, one is called glass fiber and one more is called plastic fibers. So based on the mode of propagation, we can classify another two. One is called single mode fiber and one more is called multi-mode fiber. Single mode means the mode, how they are defining mode and single mode and multi-mode means it depends upon the waveguide. So suppose if you are the waveguide, it has some different modes. It may it may guide in a single mode, or it may up to 100 modes are available. So based on the waveguide nature, we can classify into single mode as well as multi-mode. Single mode means only one mode. The light is traveled along through the waveguide along only one mode. Multi-mode means there are different modes are available to travel the to guide the light from source to destination. But in multi-mode, so there is a possibility of dispersion, because since the light is traveling in different modes from the source into destination, it may take some different time to reach into destination, because it is traveling along with different modes. So there is a possibility of difference in time. So that causes dispersion, that is called intramodal dispersion. That we will discuss in unit number 2. Now just you can should know what is single mode, what is multi-mode. Single mode means only one mode is available. Multi-mode means there are multiple modes, up to 100 modes are possible inside the fiber to guide the light from source into destination. You can see that single mode means only one mode. There is a core medium, there is a cladding medium. So here single mode fibers, it provides 50 times more distance than multi-mode, but the cost is very high. And here in case of single mode fiber, very less loss is very low, and also it offers very high distance. But here the problem is, suppose if you are a single mode fiber, we can use only laser as a source, because LED, since it is offering broader wavelength of light, it is offers less monochromatic, so it does not support LED as a source for transmitting the light in case of single mode fiber. So preferably we have to use only laser. So comparatively, when we compare with single mode as well as multi mode, this this produces high cost. The approximate core diameter is 8.3 to 10 microns. Multi-mode fibers, the cost is very less. That is, the core diameter is somewhat large when we compare with single mode fiber. You can see the difference. So there it can support single mode fiber only 10 microns. Here it is 100 microns. So because of this, we can use LED as a source. A laser, because there is multi-mode fiber, we can use LED as a source because it supports for larger, broader wavelength, broader chromatic, that is wavelength lights. So the possible LED is possible to use in multi-mode fibers, but the problem is here the light is traveled in different types of modes, so it may take some different time to reach destination. So there is a possibility of large number of dispersion in case of multi-mode fibers. So overall, single mode fiber, it produces long distance transmission is possible, but multi-mode fiber, when we compare with single mode, only less distance. But the problem is multi-mode fibers offer more loss compared to single mode fiber. Multi-mode fiber, it supports LED. Single mode fiber, it supports only laser, very low loss. So then the cost is very high in case of single mode fiber. Multi-mode fiber means the cost is very low. But overall, we can say for short distance communication, we can prefer for multi-mode fibers by using source as a LED. For long distance communication, we can prefer for single mode fiber by using source as a laser. So the diameter is up to 10 microns for single mode fiber, up to 100 microns for multi-mode fiber. So this is different types of fiber. This is the comparison table. And based on the refract index profile, we can classify one more, that is, one is step index fiber and one more is graded index fiber. Step means very simple. So throughout the core is core cladding, throughout the core the refract index is same, but in the cladding there is a sudden change, there is a abrupt change in step fashion, that is called step index. Through core it is uniform, in cladding there is a step change, that is called step index fiber. Graded means it varies based on the radial distance, that is we have to vary as a function to the radial distance from the center of the fiber. So from the step means there is uniform, the refract index is uniform throughout the core, we have to vary only in the cladding by step, but graded means from the center of the axis we have to vary as a function of radial distance, we have to vary the refract index value, that is called graded index. So further we can this is the diagram, radial distance. So we have to vary from the center of the core. Step means only step by step, but here cladding, that is graded means we have to vary as a function from the radial distance, that is a difference. So these are all the different and also we can there is classify single mode step index fiber, multi-mode step index fiber, multi-mode graded index fiber. So based on this structure we can classify these things. Okay, so single mode step index fiber, multi-mode step index fiber, multi-mode graded index fiber. Okay, so these are all different configurations of optical fiber. So I will summarize this class. So fiber structure consists of core as well as cladding. Core is used to propagate the light and cladding is used to provide the mechanical support. So based on the manufacturing we can classify, one is glass and one more is plastic, and based on the mode of operation we can classify single mode by fiber, multi-mode fiber. Then based on the refract index we can classify step index as well as graded index. Okay, that's it today's class. Then remaining we will discuss in next class. Thank you.